Well, thank you for having me here today. It's quite an honor. Very, very exciting to be able to speak at the conference. And in particular, to be able to speak about a topic that's very near and dear to me, which is building smart .NET applications with Azure Cognitive Services. So what I would like to do is spend an hour acquainting you with Azure Cognitive Services, tell you what it has to do with AI, how it relates to machine learning. And I'm going to be showing you a lot of examples, code examples, that demonstrate the concepts that I present. And at the end, I'll give you a GitHub URL to which you can go and download all of the code samples that I show, plus some that I won't show. So before we dive into Azure Cognitive Services, let's talk just a bit about AI, because Azure Cognitive Services are services that make AI available to you. The field of AI, as you're well aware, has come a long way in the last 5 to 10 years. A large subset of what we refer to as AI or artificial intelligence is something called machine learning. And inside machine learning, there's a large subset called deep learning. Now, here's what's interesting about this to me. Today, when people refer to AI, most of the time they're referring to deep learning, which is machine learning done primarily with advanced neural networks. It is the deep learning part of machine learning that most of us consider AI, and that's where a lot of the magic happens. That's how you write software that looks at a photo and identifies the objects inside it, or does real-time translation of speech from English to Russian or Russian to English. Most of that is only possible today because of deep learning, or what most of us refer to as AI. Now, if you want to build intelligent applications that use AI, there are a couple of different ways to go about it. One is you can build the AI models yourself. You can use libraries like Scikit and Keras and others, even ML.NET if you're a C# developer like me, to build machine learning models to consume in your applications and make them very smart. However, you don't always have to build those models yourself. One of the interesting things that we're seeing happening today from companies like Microsoft and Facebook and Google and Amazon and others is that they are making AI available as a service. In the Microsoft world, there's a set of services and APIs called Azure Cognitive Services that allow us to do magical things in our applications that involving computer vision, real-time speech translation, and other tasks without having to become experts in AI and build and train our own neural networks. In fact, even if we want to build and train those neural networks, it's not always possible to do it because some of the neural networks that we use today, neural networks that generate photorealistic faces of imaginary people, for example, cannot be trained on a laptop or a desktop. These models take a lot of compute power and compute time to train. They're typically trained on supercomputers or high-performance computing clusters, HPCs equipped with GPUs. One of the cool things about services like Azure Cognitive Services is, again, we can make really, really cool things happen in our applications without becoming experts in AI ourselves and without having to throw massive amounts of compute power at the models that we would have to train if we didn't have access to Azure Cognitive Services. Now, currently, there are about 25 different services and APIs that make up Azure Cognitive Services. I've listed those on the left side of this slide. We're not going to cover every one of them in detail. We are going to talk about a lot of them and show 4 or 5 of them in some detail. The computer vision API, for example, is one that we'll look at in more detail. It allows us to do all sorts of interesting things in our applications, like identify objects in photos, automatically caption the photos, generate smart thumbnails from the photos, and other things. And it's just one of 25 or so APIs that let you do these kinds of things in your app. We're also going to look at the face API. How do you do facial detection? How do you find faces in a photograph? How do you determine who those faces belong to? If you have a need to build that kind of capability into your applications, it's actually very easy to do today, thanks to Azure Cognitive Services Face API. We'll look at some of these other APIs as well, but the best way to get an idea of what they are and what you can do with them is to take a look at some of the APIs, see how they're used in applications. Before we look at the first cognitive service or code that uses it, I want to make it clear that in order to call these cognitive services APIs, you must authenticate to them. And there are three ways to authenticate. One, you can go into the Azure portal, subscribe to a cognitive service like the Computer Vision API or the Face API or some other, and you can retrieve a subscription key which gets passed in HTTP headers in each call to the service. Now, that was the original way that Azure Cognitive Services gave us to authenticate. It still works, and it works with all the services. With most of the services, not all, but most of them, you also now have the option of getting a global key that allows you to invoke that cognitive service in any Azure region. You can still also get region-specific keys if that's what you prefer. One of the recent advances in Azure Cognitive Services is that rather than use subscription keys to authenticate your calls, you can now use Azure Active Directory. Not all of the cognitive services support it yet. Several of them do, but it's something that the team is working on. So it's fair to assume that at some point you'll be able to authenticate to most or all Azure Cognitive Services using AAD rather than subscription keys. And then the third way to authenticate is with authentication tokens. Now, this doesn't apply to most of the Azure Cognitive Services. It applies just to a handful that basically require you to make a call, grab an authentication token that's typically good for 10 minutes, and then pass that in subsequent calls to the API. It's very much an outlier. It's not the way we authenticate to most of these cognitive services, but something that you should be aware of if you happen to use, for example, the real-time speech translation API in Azure Cognitive Services. So let's take a look at one of these cognitive services, learn what kinds of things we can do with it, and also see some code that demonstrates it at work. The Computer Vision API is one of the more interesting and, in my experience, more or most used cognitive services. What it does is allow you to submit photographs to it so that it can analyze those photographs. When I say analyze, it will look at the photograph. It will determine what objects are inside it. It will find faces in the photograph if you want it to. It will identify certain attributes of those faces, like the age and the gender of the person in that face. But there's a whole lot more that the Computer Vision API can do. For example, it can automatically caption your images using AI. It can grade them for adult content, which might be useful, for example, if you were building a website that you allow people to upload photos to and you wanted to do some automatic filtering of inappropriate content. And there's a whole lot more that it can do. One of the things you should know about the Azure Cognitive Services APIs is that they all are invoked over REST. Now, in my examples, I'll be using C# and I'll be using some C# SDKs for these APIs. So that will make the code simpler. But at the end of the day, you can call these APIs from any language because virtually any programming language these days supports HTTP calls. So suppose you wanted to use the Computer Vision API to grade an image for adult content. This is the call that you would put on the wire to Azure Cognitive Services in order to make that determination. Notice that in this case, this is an HTTP post performed over HTTPS, and in the body of the request is the URL of the image that I want the Computer Vision API to analyze. And by the way, you can either pass a URL in the body of the post, or you can pass the actual image bytes themselves. What you get back from that REST call is a JSON payload that might look like this. Notice that it says it's not an adult picture. Notice the adult score is near 0, but it is a, quote, racy picture. In other words, it's not necessarily an inappropriate picture, but it's one that if you're going to show it to children, you might want to hide or at least consider it before you show it to them or something like that. What about captioning an image? That's another thing that the Computer Vision API can do. Well, if I put this call on the wire over HTTPS, again, I'm identifying by URL a photo. it will look at that photo and it will attempt to create a caption for me. In this case, it captions it, a man riding a skateboard in the sand. Now, that's pretty remarkable when you think about it, that a computer can look at an image like that and come up with a caption. One other thing that the computer vision API does when you ask it to analyze a photograph is it generates a list of strings or tags or keywords, which you might use, for example, if you wanted to make images searchable. In fact, I'm going to do exactly that in an example I'll show you in a moment. Now remember, all of the Cognitive Services APIs are accessed over REST, so you can call them from any language. But Microsoft makes a number of free SDKs available, making it easier to call the various cognitive services from different languages. So if, for example, I want to call the computer vision API from C#, I could use HTTP client or some other class to put that call on the wire, get back the JSON, parse the JSON, etc. Or I could use the SDK that's available for the computer vision API for .NET developers, and that's exactly what I'm doing in this example right here. I began by adding to my project the NuGet package containing the SDK. One of the types inside that NuGet package is Computer Vision Client, which gives me access to the Computer Vision API. So I new up a Computer Vision Client object. Assuming I'm authenticating using subscription keys, I pass the subscription key in there. Then I set the Computer Vision Client's endpoint property to the URL I obtained from the Azure portal for that service. And then when I call analyze image async, I'm putting the call on the wire. Notice I'm passing in a visual feature types object there, rather than have the computer vision API do all of the things it can do with the photo when you pass it in. You can use a visual feature types array object, or IEnumerable, to tell it just what you want it to do. Here, with visual feature types description, I'm saying, give me a caption for the image, give me a list of tags describing what you see in the image. Now, because I'm making a call to the SDK, the JSON that comes back is parsed for me into .NET types, and it's easy to pull out the caption or captions that the computer vision API generated for this photo, as well as enumerate the tags, those strings describing things that it sees in the photo. Let's take a look at an example. I'm going to bring up Visual Studio here, and I already have loaded a project that comprises an ASP.NET Core website. Let me show you what that website looks like. When you bring it up, you'll initially see some photos. Actually, the first time you bring it up, there'll be no photos because you have to upload them, but I've uploaded 3 photos already. So when someone uploads a photo through this website, one of the things that happens is the site passes the photo off to the computer vision API, and it asks it to do 2 things. It asks it to caption the photo, and it asks it to generate a list of tags or keywords that we can use as the basis for a photo search feature. So for example, if I click this image right here, at the bottom you see a man riding a skateboard up the side of the hill. This is the caption that the computer vision API assigned to this image when it was submitted to it. If I click this image, I'll see the enlarged view, and this time the caption reads, "A train crossing a bridge over a body of water." So we're benefiting from captions that are generated through AI by the computer vision API, and we're also making the images searchable, because here's what happens. When I upload a photo to this website and pass it off to the computer vision API, I'm actually storing the photo in Azure Blob Storage. And I'm taking all of the metadata tags describing objects that the computer vision API found in the photo, and I'm storing them in blob metadata, then exposing that through a little search box here. So for example, if I type water, that should filter it down. Now, interesting, it thought it might have seen water in this picture. Let's try river, see if that does a little bit better. If I type river, the app is now showing me those photos that contain the keyword river as generated by the computer vision API. So not only do we have a way to automatically caption images that are uploaded, but we have a way to make the content searchable as well. And you can imagine, by the way, if there were hundreds of thousands of these images rather than just 3 or 4 of them, it might be really useful to be able to easily search for all the images that contain a river or all the images that contain a dog or something like that. So what did it take to build this website? Not a whole lot, as it turns out. It's just an ASP.NET Core website. When the page is loaded, we used the Azure Storage SDK to enumerate the blobs in a storage container, the storage container in which we've stored the uploaded photos, and then we show those thumbnail images that you saw in the UI. What's probably more interesting for now is what happens when the user uploads a photo. For that, I've built a controller method named upload. And here, we're storing that photo in blob storage. But a little bit further down right here, here's where the fun starts. I want to call the computer vision API and give it a chance to analyze this photo. So I create a computer vision client object. I pass in, by the way, a subscription key that I've already established for this API. I tell it through the visual feature types array here that I want just a description of the photo, in other words, caption and metadata. And then it's when I call analyze image async that the call goes out on the wire. When it comes back, I take the caption generated for the image and I store that. By the way, you'll notice that I'm indexing the captions array here. In some cases, the computer vision API will generate multiple captions for an image. It not only gives you those captions, it also gives you a floating point value that indicates its degree of confidence in those captions. The first caption, the 0th one, is always the one, if there are more than one, in which it has the most confidence. And here is where I'm enumerating the tags, those strings defining or reflecting what the computer vision API found in the image, which I'm storing in blob metadata and using as the basis for my search feature. So literally 8 or 10 lines of code, and I was able to do some really interesting things with image analysis in this application, building this model by hand, replicating on my own what the computer vision API is doing here would not only require a lot of compute power, it would require a lot of expertise as well. And that, again, is one of the reasons that cognitive services are so useful, because I can make amazing things happen in my applications without having to go earn a PhD in data science. So let's go back to the slides here and look at another cognitive service. Another Azure Cognitive Service is the Face API, which is designed to allow you to look at photographs, find the faces in the photographs, identify things about those faces, like what emotion is expressed on the face, whether that person is wearing glasses or whatever. But it can do more. It will also allow you to build facial databases, to train it with images of perhaps people you work with or people in your family. And then it has a facial identification API. So you could take another photograph, pass it off to the Face API and say, does this face match any of those in that face database that you trained for me? So it is a wide-ranging API that has a lot of different uses. Let's look at some of the basics here. So suppose I just want to submit a photo to the Face API and have it tell me where in the photo the faces are. That's one of the many things that it will do. And again, it ultimately involves putting a REST call on the wire, but there's a great free .NET SDK available for the Computer Vision API. There's one available also for the Face API, and I'm using that one here in this code example. So I create a Face client object and provide the subscription key that I obtained from the Azure portal when I subscribed to this API. And ultimately, I call detect with URL async, passing in this case, the image URL. Now, just as with the Computer Vision API, the Face API lets you submit an image to it by URL, or it lets you pass the image to it directly. When the call returns, then I can enumerate all of the faces that were found in the photo. Specifically, I can look at the face rectangle objects, defining where in the photo each face that it found was located. In this case, this example, I've highlighted that facial rectangle with the red box that you see. But there is much more that the Face API can do. It can not only find the faces in a photograph, it can give you information about those faces. It can tell you whether the person who with that face has hair, whether they have a beard or mustache, whether they have glasses, whether they're happy or they're sad, what their gender is, how old they are. A lot of this information is available from the Face API. So in this case, I'm passing the same photograph to the Face API. And I'm asking it not only this time to find the faces in the image, but to give me more information about the faces in the image, specifically information about the gender of the face and the age of the face. In this example here, it tells me that the face in this image is female, and it estimates her age, I believe, at 20 years old, which is about right. This is actually a photo of my daughter last summer. 2 summers ago, I'm sorry, before she went abroad to do an international summer abroad in England. So it was pretty accurate in determining how old the person in that picture was. Here's something else you can do with the Face API. You can submit 2 facial images to it, and you can ask it to compare them, to give you a value between 0 and 1, with 0 indicating 0%, 1 indicating 100%, as to how confident it is that these 2 faces are the same person. Suppose you're building a system that gives someone access to a building only if their faces match to a database. What you could do is use this API right here to snap that image, then compare it to a known image of the person, and use the confidence value that's returned to determine whether to unlock the door for them. Something else you can do with the facial API is train a database of people so that you can later have it analyze images and not only find the faces in the image, but match the faces to the people in this database that you trained. The API for doing this is pretty simple. You take your face client object, and through its person group property, you call create async. That creates what we refer to as a person group. Then you create persons inside the person group by calling client.personGroupPerson.createAsync. So in this example, I'm creating a database containing 2 people, Jeff and Lori. Lori is my wife, and I'm training the facial database with 2 images of each. You can add as many people as you want to this person group database, and the more images of each person you can provide, the more accurate it can be in identifying that person later on in other photographs. Once I have that person group or facial database trained, this is how I would take a photograph, pass it off to the Face API, and have it correlate all of the faces that it finds in the image with people in my person group, my face database. There's a little bit more work involved here, and one reason there's a little more work involved is I'm assuming that the image that we submit to the Face API may have multiple people in it, and we want to be sure to attempt to identify each one of them. But what I do here essentially is I first call the Face API's detect with URL async with the image containing the faces that I want to identify. Then I create a list of face IDs from that call, and I pass those IDs to the Face API's identify async method, as well as the ID of the person group that I wanted to try to match against. Now, for each face in that list that we input, and for each person in the database, it will tell me who it thinks those people are. It's actually quite good. It's pretty good at working past different lighting and different photos and stuff. It's not perfect, but one of the cool things about all Azure Cognitive Services is that they're constantly being improved, constantly being refined, so that they work better and better. Let's take a quick look at an example of the Face API at work. So I'm going to go back here to Visual Studio. I'm going to open a different project this time. This one is called Face Detector. Now this one doesn't attempt to identify anyone in photos, but it will take any photo that I pass to it and find all the faces in it and give me information about those faces. So this one is a Windows 10 app, a UWP app rather than a website. Let's run it and see what it does before we look at the code. So the UI is obviously very simple. It lets me select an image. Let's go find an image with a couple of faces in it right here. Let's see. Here's one. Here's a picture of my wife and daughter from a few years ago. And you'll notice that it has found two faces in the image. I'm using UWP code to draw those red facial rectangles that you see. But when I made the call, in addition to asking it to find the faces in the image, I also asked it to give me some information about those faces. And if I click one of those faces, that information will be surfaced for me. So it tells me the Face API thinks that this young lady is female, that she is 6 years of age, has no beard and no mustache, no glasses, and she is happy. And that's about right. My daughter was actually... She was about to turn 7 when this picture was taken, so she was actually 6 years old, so it's very accurate there. Now, here's my wife. It says she's 42, which was actually accurate at the time. It's interesting. This API used to think that she was 40 years old, but they've improved it, trained it more, so it's nailing her age exactly. So once more, it realizes she's female, looks like she's about 42 years of age, and the emotion on the face is happiness. That emotion is one of 8 different emotions that the Face API is capable of detecting. It can detect happiness, fear, anger, surprise. One of the options is neutral if there's no emotion expressed there. So it's pretty remarkable how much information it can extract from these faces for you. And as for the code that makes this thing work, it's pretty simple. Most of the code is just UI code so that the user can pop up that file picker and select an image and to actually show the image that the user selects. The work done with the Face API is pretty simple. Each time an image is uploaded, we create a Face client object. We created an enumerable of face attribute types indicating that we want to know the gender, the age, the emotion, and whether each face in the image has glasses or facial hair. And here's where the call goes out on the wire to the Face API, detect with stream async. Notice I'm not passing a URL. Here I'm leveraging the option that lets me pass the image itself in the call. And once that call comes back, I enumerate all of the faces that were found in the result, draw that red rectangle, and then wire up some pointer event handlers so that, for example, I can click one of those faces and get more information about it. So most of this code is UI code. The real work was done with basically one line of code right here, the call to the Face API to allow it to analyze that photograph for me. So let's go back and see what else we can do, because that's just 2 of 25 APIs. One of the most interesting and potentially useful Azure Cognitive Services is one called the Custom Vision Service. What this one does is it relies on deep neural networks, specifically convolutional neural networks, to look at images that you submit and classify those images in various ways. Now, unlike the computer vision API, which basically has a fixed set of tasks or analyses it will perform on the photo, with the custom vision service, you train a vision model to accomplish a domain-specific task, something that perhaps helps you solve a business problem at your company, and then you invoke that model using a REST API. I want to show you what I mean by that in just a moment, but before I do, I want to say a word or two about how this thing works and what's actually happening under the hood. When we talk about deep learning today, we're primarily talking about neural networks, which have added an entire new dimension to machine learning. It's because of neural networks that we can do very accurate real-time speech translation, identify objects and photos, and do a lot of other things. There are a lot of different types of neural networks, but one of the most prominent is the convolutional neural network, or CNN. These types of neural networks tend to be very good at tasks involving computer vision. For example, looking at a photograph and telling you whether that photograph contains a cat or a dog, or perhaps if the photo depicts a part coming off of an assembly line, whether that part is defective or not. This, in a nutshell, is how convolutional neural networks work. They typically have a series of convolution layers followed by pooling layers. And here's what's going on. In the convolution layer, features are being extracted from the image. I'll say more about that on the next slide, but essentially we're doing edge detection from various angles on the image so that we can learn to recognize things like the shape of a cat's ear or the shape of a dog's tongue. The convolution layer is succeeded by a pooling layer whose job is generally to shrink the image down to half of its size using subsampling. Why do we do that? Because we want to be able not only to recognize micro features in an image, but macro features as well. You may have a very detailed image containing a picture of a cat, and before any convolution in pooling is done, the edge detection finds things like the cat's ears. But when you by the time you have subsampled that image, you've pooled it a few times so that the fine detail has gone away. Now edge detection might reveal the shape of the cat's head. So convolution layers find features in images, pooling layers subsample the images, cut them down in size so that we can recognize not only macro features but micro. At the end, we take all of these features that we've extracted and we feed them through a fully connected layer of neurons in a traditional neural network. At the end, it can do image classification for us. We could train a network like this one to tell us, for example, whether an image contains a dog or a cat or a defective part or a non-defective part or what have you. Now, you and I will probably never build this network ourselves. To actually make it work and work really well, it takes vast amounts of compute power to train it. But thanks to the custom vision service in Azure, it's basically going to provide this network for us and customize it to accomplish or to solve whatever problem we want it to solve. Before I show you how that works, let me say a little bit more about what is happening with the so-called feature mapping in a convolutional neural network. If you've ever used Photoshop, you know that you can use Photoshop to blur a photo, to sharpen a photo, to do edge detection, to do embossing and things like that. Many of those graphical effects work by passing convolution kernels, that is, matrices of numbers weighted in a certain way, over every pixel in the image and replacing the pixel value with a computed pixel value from the convolution kernel, the matrix, and the surrounding pixel values. If you look at the hot dog image in the upper right, if I take that image and I run the convolution kernel underneath it over that image, the resulting image is shown in the lower right. We've essentially eliminated the color from the image, but we've done a really good job of detecting the features in the image. This is essentially how convolution kernels work. It's the basis for feature detection in convolutional neural networks, and the algorithm that's used there is basically the same algorithm that tools like Photoshop have used for many, many years. Now, I'm going to actually train a model for you in just a moment using the Custom Vision Service portal. But once I train it, I'll then want to use an app to call it. And this is what the code to call it will look like. Once more, I'm leveraging an SDK that's available for the Custom Vision Service, and I'm making a call, but this time to invoke a model that I've already trained. So let's go back to Visual Studio and see this at work. First, I'm going to open up in Visual Studio another Windows 10 UWP app named Not Hot Dog. But before I do anything in Visual Studio, I'm going to go out to the Custom Vision Service portal, which lives at customvision.ai. And there's a process I go through to build and train my own neural network. Let me first get signed in here. I'll sign in with my Microsoft account. And looks like it's going to may make me go through all the terms of service again. There we go. And yes, what I want to do is create a new project. Now, what I want to do is train a convolutional neural network to determine whether a photo that I provide to it contains an image of a hot dog, contains pizza, or contains sushi. So this is a very domain-specific problem, and I'll have to do some training to make sure that this thing can recognize those different types of objects. So we're going to start off by creating a new custom vision service project. We'll just call it My Hot Dog. We can call it anything we want. And let's see, resource. Yes, I'll use an existing resource group there in Azure. We're going to ask it to do image classification. It's going to be a multi-class problem, single tag per image. As you'll see, I'll tag each image with a label like hot dog or sushi or something like that. And we can, if the computer vision task that we're doing involves classifying images using food or landmarks, the custom vision service can make this network slightly smarter by knowing that in advance. So I'll just ask it to create the project. And then what I need to do is train this project, which will end up being an instance of a very sophisticated convolutional neural network with some images. So let's do this right here. I have some food images. I don't want to use those. Let me pop out here to another place where I store some food images for training. The one I'm looking for is it deep learning? Let's find out. Test. Yeah. Okay, so I'm going to grab some hot dog images here. And the more images you train with, the better. I'm just going to do 10 or so. Vision service that I want all of these images tagged as hot dog. And I'll upload those images. Now, if I wanted to be able to identify sushi, pizza, other types of food, I'll need to pass in some other images to it as well of those particular items and tag them accordingly. So let's go back here to, we'll do add images again. And let's see here. Well, I'm going to go to a different GitHub repo this time and grab some images. The one I'm looking for this time is... Did I put that under Cognitive Services? No, I did not. I put that under, let's see here. Well, I tell you what we'll do. Let's just train this model up with some non-hot dog images rather than take time to find them. So there's a sushi image. I'll just call these not hot dog images. How about that? And I'll give these the label, not hot dog. And the idea here is that to make this neural network as smart as I want it to be, I can continue to upload images, to tag them. I could make it so that it could recognize thousands of different types of objects if I wanted to this way by training it up with my own images. Once I've uploaded and tagged all the images, I click train. Now, under the hood here, what's happening is in Azure, a very sophisticated convolutional neural network is being instanced, and it's essentially being retrained using a technique called transfer learning so that the existing neural network can digest the images and the tags that I've given it and be able to recognize those objects and images as well. Now, it tells me it's incredibly accurate here. The truth is, because I only passed in 20 or 30 or 40 images, it's probably not 100% accurate. Remember, the more images you train it with, the better. But once you do this, here's the cool thing. You can go to publish, and you can publish this as a web service. And once you've published it, you can click this prediction URL button and get an authentication key and an endpoint, a URL by which to call it. Now, I've already done some of that. I've already trained a model this way to differentiate between images containing hot dogs, sushi, and pizza, and I've built a UWP client for it. So here's what it looks like. Now, I can select an image, and I will select one of these images here. There's a hot dog image. It's passed off to this custom model that I trained with the custom vision service, and it says, yep, it's a hot dog. What if I try a different image like this pizza image? Will it think it's a hot dog? It says not a hot dog. I'm not showing it here, but under the hood, it's actually telling me how much confidence it has that what it's looking at is a hot dog or it's not. Here I pass in a sushi image, and it tells me it's not a hot dog. So with the custom vision service, I can train my own very sophisticated, very deep convolutional neural network to do domain-specific image classification tasks, and then I can build apps that do things like this, that identify objects in images or identify characteristics of those images. So we're almost out of time here, but there is something else I want to show you. All of the Azure Cognitive Services APIs that we've dealt with up until now have to do with images, but I don't want you to think that that's the only thing it can do. It can also do real-time speech translation, text analytics, etc. In fact, there's a whole API called the Text Analytics API that, among other things, lets you do sentiment analysis on text. Sentiment analysis is something that's generating a lot of interest today. Maybe your company's marketing department wants you to write an app for them that will pull tweets off of Twitter that target their company and analyze them for sentiment so that they get an automatic heads up if, for example, those tweets are trending negative. This is a really easy problem to solve using the Text Analytics API in Azure. Here you see I create a Text Analytics client object. Ultimately, I call sentiment async on it, pass in a string of text, and it returns a number from 0 to 1, indicating the sentiment in that string, 0 being negative, 1 being positive. I can also have it analyze multiple strings at once rather than make multiple round trips up to the service and back, which might be really useful if I'm downloading, say, 500 tweets and wanted to analyze all of them all at once. So again, let me show you an example here. It's a fairly simple one, but one I think you might find interesting. This one is called Tweet Analyzer. And what it lets you do is type in a Twitter hashtag. Let's see what people are tweeting, for example, about .next. When I click Analyze, it'll pull down the latest tweets regarding with that hashtag. It will show them to you, and it will pass them to the Text Analytics API to analyze them for sentiment. It says the average sentiment is 0.56, which is more positive than negative. That's a good thing. Sounds like people are liking what they see at .next. What did it take to do that? Well, not a lot. I'm using a separate NuGet package here called Tweet Envy to go up to Twitter and pull down the latest tweets with the hashtag I specified. This does mean that I had to go to Twitter and register as a developer. That's not a big deal. It's free, but I did have to do that. Here's the code that goes out to Twitter and pulls down all the tweets with the hashtag. And then I want to not only show those to the user by adding them to that list box that you saw, but I want to analyze them for sentiment. So what I do is I create a Text Analytics client object. I've already created a list of multi-language input objects containing the individual tweets. And then I call sentiment batch async, as you see right here, to submit all of those tweets to the Text Analytics API and get back all of the sentiment scores. What I then do is I use a little bit of LINQ to average the scores for sentiment for all of those tweets and show them to the user in a message dialog right here. So really, really easy to do text analytics, as you can see right there. Now, let's go back to the slides for just a moment. The Text Analytics API, among other things, will let you analyze text for sentiment. It will do other things too that I didn't mention. For example, it will pull keywords out of documents, pull key phrases and things like that. It actually has a lot of interesting things that it will do in order to help you analyze documents. There's also an API called the Translator API. Now, 10 years ago, especially 20 years ago, computers weren't very good at translating text from one language to another. They've gotten much better in recent years, and just in the past 5 years or so, they've really gotten over the hump to where they can sometimes do this more accurately than humans can, thanks to neural networks that have been specifically trained to do text translation. So if I wanted to use the Translator API to translate something like hello world from English to French, it's relatively easy to do. Now, currently, there is not a .NET SDK available for the Translator API. That doesn't mean I can't make calls to it. It just means that I have to do things in C# a little bit more manually by using my own HTTP client or something like that. So one nice thing about this example is that it does demonstrate that, yeah, you don't have to have .NET SDKs to call these APIs, and it reveals a little bit more about what's going on under the hood when you call one of these APIs. So in this example here, I want to convert hello world, which is English, to the equivalent in French. I don't have a .NET SDK wrapping this Translator API, so I'll just do it manually. I begin by creating an HTTP client object, and then in order to authenticate, I need to include the subscription key that I obtained from the Azure portal for this service in an OCP APIM subscription key header. Now, this is what's happening under the hood when you use these .NET SDKs. Here you just see it more out in the open. We are in line 2 of this code, literally adding this header into the call that's going to go out. Then we create a JSON object containing the text hello world and insert it into the body of the post that's about to go out. We create a URL that addresses the Translator API. And notice on the 4th line here, the query string that I've highlighted in yellow, 2 equals FR, is how I'm telling this Cognitive Services API that I want the text that I input to it translated into French. Now, this API supports about 60 different languages, so I could say 2 equals RU, for example, for Russian. And by the way, you can have a single document or phrase translated into multiple languages at once by including multiple 2 equals language identifier in your query strings. Then on line 6, I call post async. The call physically goes out on the wire. Now, without an SDK to help me here, it's JSON going out on the wire, it's JSON coming back. So I read the JSON response, use JSON.NET to deserialize it. And then for each of the phrases that I passed in up here, I'm just passing in one, but for each of the phrases, I'll go once through this for each loop. It tells me that it translated this phrase into French, and that the translation reads Salut tout le monde, which is a pretty good rendition in French of hello world in English. So that's another API, the Translator Text or Translator API, which was formerly called the Translator Text API. Now, if you want these code samples for yourself, it's very easy to find them. You can simply go to this GitHub URL right here. It is a public GitHub repo, and I've posted all of the code samples that I just showed you, plus some that I haven't showed you. Feel free to download these, play with them yourselves, share them with friends and colleagues if you want, and do check back there from time to time because I'm constantly writing new samples and posting them there and revising existing samples, especially when Microsoft revises the .NET SDKs for these services. Now, let me pop over to GitHub real quick and show you something that you need to know in order to use these samples. So let's go to GitHub. And I'm going to go into this repo, which is right here, the Cognitive Services repo. And here you'll see examples, like if you want to look at the IntelliPix example, the website that uses the computer vision API to analyze photos, you'll find the Visual Studio solution right here. Now, here's the big thing you need to know in order to run these samples. None of them will run as is. There's a little bit of work you have to do first. The versions of these samples that I ran in my demos worked because I had already subscribed to the various cognitive services APIs and gotten authentication keys or subscription keys for authentication. You will have to go register for these APIs yourself and plug those keys into the code. In the case of this IntelliPix example, if you look in appsettings.json, you will have to create an Azure storage account in order to run this sample and put the storage account connection string in here. You can get that connection string from the Azure portal once you've created the storage account. And you will have to, in the Azure portal, subscribe to the Computer Vision API and plug the API key and the API URL in for these values right here. So again, none of these samples, all of these samples require subscriptions to the various cognitive services that they use. I give you all the code, but you will have to go create your own subscriptions. I can't give those to you for obvious reasons. One nice thing is, yes, you do have to have an Azure subscription to use most of these cognitive services APIs, but the APIs don't always cost. In fact, most of them have a free tier that's fine for development, so you can try out apps and websites that use the computer vision API and other things without having to actually pay Microsoft, without having anything charged to your credit card that's connected to your Azure subscription. And in fact, if you have Azure subscriptions through MSDN, for example, or through other sources that to which you don't have a credit card attached, that's fine too. You can use these cognitive services and their free tiers without running up any charges on that subscription that you've been given. So with that, that brings us to the end. Let me go backwards real quick. I want to make sure that there's nothing that I missed. I think we got everything. So why don't we do this? Why don't we go ahead and turn the floor over for questions, for comments, etc. Because I know when I do these presentations, there are almost always lots and lots of questions that arise from them. I'd be happy to answer those questions for you if I can.
So, okay, I don't see any questions from chat at the moment, but I could ask my own. So, for example,
okay, good.
Yeah, as a good evangelist who loves to sing, you described all the brightest sides, but what about things when you shouldn't use the APIs? What do you think is not the best moments to use cognitive services?
Yeah, it's a great question. When would I not want to use cognitive services? There are two things that would make me consider not using them. One is trying to use them for something that they're not designed to do. For example, I've been asked on a number of occasions, could I use Azure Cognitive Services to predict the stock market so I can get rich? So the answer is no. There is no Azure Cognitive Services service that's designed to allow you to build generic machine learning models of the type that you might build if you wanted to try to use machine learning to predict the stock market. So number one, make sure that you use these services when it's appropriate to use them. If you have an image classification task, like looking at photos of parts coming off an assembly line to determine which parts are defective and which aren't, that is a fantastic use for the custom vision service. If you own a website and you want to automatically filter out inappropriate photos that users upload so that other users won't see them. That's a perfect application for the computer vision API. But for building a generic ML model, you would not use that. The other consideration is the ethics surrounding AI. In the United States, there's been a lot of news lately, as you might have seen, with riots and protests going on. And just a few days ago, Amazon announced that it is no longer going to sell facial recognition technology to police departments here in the United States. Very much a reaction to some of the things going on here. And I won't try to render a judgment on whether that's a good thing or a bad thing. I would say always be cognizant of the ethical implications of the cognitive services that you use. If you are using the Face API to identify people in photographs, realize that there may be some privacy issues there that could be broken in you doing that. So be cognizant of that. The good thing is most cognitive services APIs are very straightforward and not very controversial. Translating text from one language to another, translating text to speech or speech to text, or even doing real-time translation of speech from one language to another, all things that cognitive services can do. There's nothing I'm aware of that's very controversial around the services. So to sum up there, I realize that was a long answer to a short question, but to sum up, use cognitive services when your business problem maps well to what they provide. Don't waste time trying to solve problems with them that they're not designed to provide, and always be aware of the ethical implications surrounding your use of these cognitive services.
Okay, yes, that's a great thing. And by the way, you mentioned Face API, and I've not really played with exactly this thing a lot, so I'm kind of curious, is it works good with, I don't know, when it's trying to recognize people with something changed, I don't know, when you're wearing or not glasses, when you're with beard or without it, etc., etc. So is it works well when you have people in different conditions?
Generally it does, but it depends on how you define well, right? So I've actually done a fair amount of experimentation with this. I'm interested in knowing, let's say that we teach the Face API what Jeff looks like. Maybe I train it with 10 or 50 or 100 images of my face with different expressions, different lighting conditions, things like that. How good is it at then recognizing me if I'm 5 years older, or if I've grown facial hair? So you'll just have to try it for yourself. In terms of the facial hair, if you have grown light facial hair like a mustache or a light goatee or something, it's generally pretty good at determining that it's still you. If you go to a heavy beard, it's not so good at it, in part because that heavy beard is hiding features of your face that it might be relying on. I have found that in my experimentation, which is not scientific, but in terms of like if I want to train it, the Face API to recognize a particular person, I start with photographs of that person. And if it's a photograph of my wife or my kids, chances are not all the photographs are current. Some may be from a few years back. It is reasonably good at accounting for that. However, it cannot magically look at a photo of a person when they're 20 years old and correlate that to a picture of them when they were 5 years old. Too much has changed. So generally speaking, when you're training it to recognize people, obviously it's better if they haven't changed too much, if they haven't grown heavy facial hair or something. It's better if the training images represent a person at about the same age they are now. But it does have some ability to get around that because of the way the facial algorithms work.
Okay. Actually, just why I'm asking this, I was working on face recognition topic, which was kind of topic of my diploma. And what I was amazed when I first used iPhone is that like by not really one photo, but by set of kind of same photos from just different angles, it is able to recognize you in very different conditions, I'm still kind of
Yes.
shocked how exactly they did it, because usually face recognition works just by key points of the face, like nose, eyes, and so on, and it changes pretty hard. I don't know, with glasses, for example. So it's kind of hard to recognize.
Yeah.
Yeah, actually, I was kind of interested. Could Microsoft do the same thing at this public API or not? Because it's really something very complicated. I couldn't say I have no idea, but I'm not really sure how exactly this thing works.
You're right. It is very complicated, and since you've studied this in college, you know that there are different ways that we recognize faces. I mean, in some cases, it's done using statistical machine learning models using support vector machines. Although for the most part today, it tends to be done more using neural networks. So, like you, I carry an iPhone. I use facial recognition to unlock it. And I didn't have to train it with 100 pictures of me. I held my iPhone up one time, right? And let it look at me. And it's very good at differentiating between different lighting conditions and things like that. I don't know exactly what Apple's doing there, what algorithms they're using. I'm not sure they've even published it. But you said, could Microsoft do something like that? Sure. Windows Hello, probably less well known than facial recognition unlocking on an iPhone. But Windows Hello lets you unlock your Windows PC using facial recognition. It also is pretty good at using one photo as opposed to a batch of 100 training photos. Not sure what algorithm they're using there either, but both of those demonstrate that it can be done. One thing you'll find about the Face API, and this is also true of the custom vision service in Azure. Generally speaking, when you train any kind of image recognition model, you want to train it with as many images as possible. Both of these APIs are remarkable at achieving high accuracy with literally just a handful of training images. So, in fact, with faces and stuff, I don't have to have 100 images with the Face API. I've actually been pretty successful in building something like Windows Hello, where I give it one image of my face, and it is pretty good at recognizing me when I give it other images.
Okay. And we have a question from chat. So Vadim is asking, is there any way to automatically generate text for text, not for image? And by the way, as far as I remember, there is no, and how do you think why? What's the problem?
So to make sure I understand, is there any way to generate text for an image?
For text. We have text for an image, but is there any way to generate text for a text?
To generate text. Oh, yes, to do optical character recognition, for example.
Yeah.
Absolutely. It's one of the many things that the computer vision API will do for you.
No, not in terms of computer vision. I mean, in terms of speech API or any text-related APIs. So we, for example, able to determine sentiments of the text, but do we able to determine some tags for text? So we have tags for image.
Oh, tags for the text.
Same way to do it. Yeah.
Yes, in a way. So tags per se, no. But let me see if I still have the slides up here. Let me go back to the Text Analytics API right here. So one of the things you can do with the Text Analytics API is you can do key phrase extraction and topic detection. Depending on exactly what you're looking for in those tags, you might find that the key phrase extraction would give you what you want and or the topic detection. So I would try either or both of those and see if they give you what you want. But yeah, their job is to take a macro look at the text to understand the meaning being connoted in that text and to extract topics and key phrases. They will also do language detection. They'll look at a document, tell you what language it's in, even works with mixed languages. It will tell you, I see English, French, and Russian in this document, for example.
So I guess
yes.
I guess the thing you could do in case you need to generate any kind of text, in this case, you could just separate your text in pieces, some this kind of
Sure.
same meaning, and just extract topics and use these topics as text. I guess
Right.
this is things that could
And,
work.
and
Yeah.
yeah, you're exactly right. And think about this too. There are a lot of interesting possibilities because we have the ability to, with the Cognitive Services APIs, for example, to translate speech into text in real time. So imagine this. You want to build a tool that looks at a Zoom video feed, for example, takes the audio, transcribes it into text, and then feeds that text into the Text Analytics API to do sentiment analysis, topic detection, etc. So it's often by combining these various cognitive services APIs that we come up with interesting and innovative solutions to help us solve those business problems.
Okay. And another thing that I'm curious about, would you personally maybe use cognitive services as some component at big systems that requires high reliability in this exact piece that uses cognitive services? Because just to explain, I usually try to avoid using it in this case just because you're never sure that API gonna work, that API never gonna give you some kind of very unexpected thing, or that API won't be blocked because you're a police. In this case, sorry to discuss it.
That's true. And one downside to cognitive services, to follow up on that, is that you do have to have an internet connection to call them, right? So I don't think about that so much in terms of reliability as in the context in which it's being used. For example, maybe I'm writing a mobile app for my iPhone or for an Android device, and I wanted to have some intelligence capabilities. Maybe I want it to do sentiment analysis on tweets or something like that. I could use Azure Cognitive Services to do that. But what if I had data turned off on my phone? Or what if I was out camping somewhere? I was out in the woods where I don't have an internet connection. Without an internet connection, these services will not help you. So if I need to make sure that I control everything, or I need to make sure it works without an internet connection, I would then consider building my own models. Now, in some cases, you and I can build a sentiment analysis model pretty easily in C# or Python and train it on a laptop. We cannot easily build a local neural network that determines whether an image contains a hot dog. But let me point out something else that may be interesting here. More and more, vendors like Microsoft and Amazon are considering delivering cognitive services capabilities and doing so offline. Already with the custom vision service, think back to that demo where I trained it to recognize hot dog images versus non-hot dog images. When I trained the model, that neural network was instantiated in the cloud, and yes, calls were going out to it to determine whether an image contains a hot dog or not. What I didn't show you is there is a button I can click to create a local version of that model. And I can choose between Core ML if I want to run it on an iOS device, or a TensorFlow model if I want to run it on an Android device, a Windows device, or some other. So by allowing us to export the model that way, I could build that exact app that determines whether an image contains a hot dog using that sophisticated neural network, but without paying Microsoft any money, without a connection, without making calls, because I could consume it locally right there inside my app. And in fact, it's one of the reasons I'm very excited about ML.NET, Microsoft's relatively new ML and AI library. ML.NET makes it almost trivially easy to take a TensorFlow model trained with and exported from the custom vision service and invoke that model from a C# app with no network connectivity required, no cost, everything happening right there in the app. So the combination of the two solves all of those problems, and it's something that you'll probably see more going into the future. You will probably see more cognitive services provide a local disconnected option like the custom vision service does today.
Yeah, hope so. That would be really great. By the way, just speaking of tasks that cognitive services could solve, I once built neural network to recognize surgical instruments on the table, and like to always have a list of instruments on the table at this exact moment. And how do you think? Is
That's
this something we
cool.
can solve with cognitive services?
Could I do that with cognitive services?
Yeah. Because I built just neural
So,
network myself. I was not sure that at that
yeah,
exact moment, I guess, there was no image recognition service that we was able to,
right.
uh, yeah, to
Yeah.
train. But maybe
So
these
yes,
days.
you could do that today with cognitive services. Specifically, you would use the custom vision service. You would train a model with photos of the different surgical instruments. And then you would either make calls to the service to invoke that model or export it to Core ML or TensorFlow and invoke it locally. So absolutely. And you make a really good point there. You built your own neural network to do that. That required quite a lot of expertise. You probably built a convolutional neural network to do that. It probably took a considerable amount of time to train. And part of the point of cognitive services is rather than invest all the time that you had to invest to build that neural network today, once I know about the custom vision service and am willing to generate a few training images to train a model with, I can do that with much less time and much less knowledge required. And there's a trend here that is happening that is very important. 5 years ago, if I wanted to build the model you just described, the neural network that recognizes different surgical instruments, I really had no choice but to go to university and learn a lot about convolutional neural networks. Today, thanks to the tech giants like Microsoft, Google, Facebook, and thanks to APIs like Cognitive Services and Amazon Recognition, AI is being commoditized. The idea is that if you're a software developer, you shouldn't have to go get a PhD in data science in order to build smart applications. So the tech giants are helping us do this with APIs like these. You'll see more of these in the future. They will get more and more sophisticated. And the whole idea is to make AI something that is very approachable to the average developer. And it's the big reason I'm so excited about cognitive services and the equivalent services from companies other than Microsoft.
Thank you very much. Thank you for your talk, Jeff. We've kind of out of time, and for
Understood.
we have a discussion zone in the Zoom, so you can just join right now if you have questions to Jeff and Roman. Thank you, folks. See you there.
Yeah.